NASA reveals the secret of Mars' mysterious spider structures. Imagine stepping onto the Martian surface and seeing intricate patterns resembling spider webs stretching across the landscape. These aren't actual spiders, but rather fascinating geological formations that have puzzled scientists for years. But here's where it gets controversial. NASA has just unveiled the secret behind these mysterious structures, revealing how they form and what they tell us about the red planet's climate. These unique formations, known as Kiefer's Zoo, are predominantly found in Mars' southern hemisphere. They consist of complex systems of channels that can extend over a kilometer, with no direct equivalents on Earth. For the first time, researchers at NASA have successfully replicated these formations in a laboratory setting, providing valuable insights into their origins. Scientists long suspected that carbon dioxide ice played a crucial role in the formation of these structures. As winter descends on Mars, much of the planet's atmospheric CO2 freezes, creating a layer of frost. When spring arrives, this ice transforms back into gas, a process that can lead to the creation of these distinctive geological patterns. Lauren McCune from NASA's Jet Propulsion Laboratory in Southern California explains, "These spiders are both unusual and beautiful. Our experiments will help us better understand how they form." The process begins when sunlight penetrates the translucent carbon dioxide ice, warming the underlying Martian soil, or regolith. This warmth causes the lower layer of ice to sublimate, turning directly into gas without passing through a liquid phase. As the gas accumulates beneath the ice slab, it builds pressure, eventually cracking the ice and ejecting high-speed jets of gas and dust. These jets carve out the intricate spider-like structures that we observe on Mars. Recreating Martian conditions in the lab presented significant challenges for the NASA team. They needed to achieve extremely low temperatures, around -185 degrees Celsius, and simulate the thin, rarefied atmosphere of Mars. This was accomplished using a specialized test chamber called the Dirty Under Vacuum Simulation Test Bed for Icy Environments, or DUSTY. Inside DUSTY, a substance resembling Martian regolith was placed in liquid nitrogen, and CO2 was introduced, which quickly froze into ice layers. Through these experiments, the researchers discovered that specific conditions are necessary for the formation of these spider-like structures. Sunlight passes through the transparent carbon dioxide ice, heating the regolith below and causing further sublimation of the ice. The resulting buildup of gas under the ice exerts pressure, causing it to crack and release gas and dust, sculpting the unique patterns we see. While gas release is primarily responsible for creating these surface features, the team also observed that some cracks might form due to thermal stress rather than gas erosion. Different features emerged based on variations in gas release and ice thickness. Dark spots appeared where carbon dioxide broke through the ice, releasing dust, while these spots were often surrounded by bright halos, likely formed by the deposition of frost from gas plumes. Despite these breakthroughs, many questions remain about these intriguing formations. Why don't they continue to grow indefinitely? And why are they not found across the entire planet? Unraveling these mysteries could provide crucial information about Mars' geological history and its potential for sustaining life. What do you think? How might these findings impact our understanding of Mars? Share your thoughts in the comments. NASA discovers heart-shaped landforms on Mars' cosmic love and space wonders. Imagine finding love in the most unexpected places, even on another planet. NASA has recently unveiled a series of heart-shaped formations on Mars, turning the red planet into a celestial canvas of affection. In a charming revelation for planetary science, the Mars Reconnaissance Orbiter, EMBRO, has captured numerous images of heart-shaped landforms scattered across Mars, from the vast plains of Arabia Terra to the rugged southern highlands. These formations, while evocative of love and romance, are actually the result of millions of years of natural processes. But here's where it gets controversial. Some might see these shapes as signs of extraterrestrial affection, but scientists assure us that they are simply the work of nature. Here's how Mars carves out its own version of a heart. 1. Impact craters asterisk. When small meteoroids strike Mars, they expose lighter sediments beneath the surface, creating craters that sometimes take on heart-like shapes. 2. Erosion and volcanism asterisk. Over time, wind and water erosion, along with volcanic activity, can form mesas and depressions that resemble hearts. 3. Lighting and shadows. The angle of Martian sunlight can create optical illusions, enhancing the appearance of ridges and dips to form these romantic outlines. Dr. Alicia Grant, a planetary geologist at NASA's Jet Propulsion Laboratory, puts it poetically. It's a moment where the precision of science meets the whimsy of poetry. We're seeing nature's randomness as a symbol of something deeply human. And this is the part most people miss. NASA has been sharing these captivating images around Valentine's Day each year, sparking widespread fascination. One particularly playful post even suggested that Mars has been secretly playing Cupid all along. This trend has taken off online, with space enthusiasts tagging and discussing their favorite heart-shaped formations. Some even argue that Mars deserves a new moniker, the loveliest planet. Beyond their aesthetic appeal, these formations hold significant scientific value. They help researchers study erosion patterns, geological layers, and ancient water flows. But perhaps more importantly, they bridge the gap between science and storytelling, inviting the public to engage with space exploration in a more emotional and relatable way. When a planet 225 million kilometers away starts looking like a symbol of love, it's hard not to feel a cosmic connection. So what do you think? Should we start calling Mars the loveliest planet? Share your thoughts in the comments. Eerie, beautiful, and unbelievable discoveries on Mars. Volcanoes, illusions, and mysteries. The Red Planet, often referred to as Mars, is a treasure trove of astonishing natural phenomena. Among its most remarkable features are Olympus Mons, the largest volcano in our solar system, and the vast Borealis Basin, which spans nearly 40% of Mars's surface. However, as we delve into the exploration of this enigmatic planet, we frequently encounter a mix of genuine discoveries and misleading optical illusions, both of which contribute to the allure of our cosmic neighbor. The face of Mars. In 1976, NASA's Viking 1 orbiter transmitted a peculiar and somewhat unsettling image from the Cydonia region of Mars. This image appeared to depict a massive human-like face protruding from the Martian landscape, igniting a flurry of wild theories about an ancient Martian civilization and its architectural wonders. In truth, this so-called face is merely an optical illusion created by the interplay of light and shadow at the moment the photograph was captured. Years later, the Mars Reconnaissance Orbiter took higher-resolution images of the same area, revealing that the supposed face was actually just a flat-topped hill, scientifically known as a mesa. Planet of the Apes. Fast forward to 2020, when a YouTuber reignited another outlandish Martian theory by claiming that a photo from NASA's Curiosity rover showcased a creature resembling a gorilla and its offspring. This influencer speculated that the figure could also be a bear or even a statue, clearly mistaking a pair of oddly shaped rocks for something far more sensational. It's important to recognize that individuals with specific beliefs or agendas often interpret images in ways that align with their views. Additionally, our brains are wired to recognize familiar shapes and patterns, even in contexts where they do not exist. This phenomenon, known as pareidolia, explains why we frequently perceive faces in inanimate objects and why people continue to discover unexpected shapes on Mars. A doorway to nowhere. In May 2022, another image captured by Curiosity sparked excitement among conspiracy theorists, as some claimed it depicted a doorway carved into a rock face. While the unusual feature does resemble an artificial entrance, it's crucial to consider various factors before jumping to sensational conclusions. Shadows, perspective, and natural rock formations can easily combine to create such images, providing a more rational explanation than the wild theories proposed by online alien enthusiasts who are eager to find evidence of a Martian temple. The spiders from Mars. While we continue our search for Ziggy Stardust, we have at least identified his fictional bandmates, the spiders from Mars. These spider-like formations were first documented in 1972 by NASA's Mariner 9 probe in a region known as Angustus Labyrinthus, or Inca City, located near the south pole of Mars. Fortunately, scientists have confirmed that there is no race of giant Martian tarantulas. They have developed a theory known as the Kiefer model to explain the formation of these arachnoid shapes. Essentially, Sunlight interacts with layers of carbon dioxide that accumulate during the winter, transforming them into gas that cracks the overlying ice as it escapes. Zebra rock. Not every peculiar feature on Mars is an illusion. Some are genuine geological anomalies that have left scientists puzzled. One particularly fascinating example comes from the Jezero crater, where NASA's Perseverance rover discovered a strikingly unusual striped rock in 2024. Officially named Freya Castle, this intriguing object has been nicknamed Zebra Rock due to its distinctive appearance. Researchers describe its texture as unlike any other rock previously observed on Mars. Currently, our understanding of its chemical composition is limited, making it challenging to explain the rock's unique appearance. Although the stripes may have resulted from igneous or metamorphic processes,